Hello, today I'll be explaining to you how to solve question 13 from Energizing Physics 3.2. In this problem, a person is pushing a box, well, a chair, but boxes are easier to draw, right? And so she pushes the box for a distance of 1.5 meters. She's pushing with a force of 40 newtons. The force of friction is 25 newtons. The box is initially at rest. The mass of the box is 10 kilograms. Yeah, G. And so, in the first problem, we're trying to find the K of the box after she finishes pushing. And so the important equations to remember are that E1 plus work equals E2, and that work equals force times displacement. And so to solve for A, since the box is at rest initially, the initial energy is 0. And so the work done is 1.5 times 40 for the work of the push, and 1.5 times negative 25 for the work of friction, and that will equal the Ke at the end. And so multiplying this out, you get 60 minus 37.5, or Ke equals 22.5 joules. And so that's A. Next off, for B, you're trying to find the distance that the box will go after the person lets go of the box. And so for B, the initial energy will be, at this point, 22.5 joules. And the only work that'll be acting on it is the work of friction. So negative 25 times x, the distance, and the speed at the end will be 0. Well, the energy at the end will be 0 because speed is 0 when the box is at rest. And so you get 25x is equal to 22.5, or displacement is equal to 0.9 meters. And finally, in C, you're trying to find the force that the person would have to push at if she wants to increase the box's speed from 1 meters per second to 4 meters per second. So V1 equals 1 meter per second, V2 equals 4 meters per second. And so the initial energy is equal to the Ke at that point plus the work of friction, which is 1.5 times negative 25, plus the work of the push, which is 1.5 times the force, and that is equal to the Ke at the end. And so solving that out, we get 580, what's that number? Negative 37.5 and 1.5 F. And so when you put everything onto this side, you get 1.5 F is equal to 112.5, or the force of friction is, the force of the push is equal to 87.5 newtons.